You're listening to MedX, the Medical Extrusion Podcast. Presented by US Extruders. Extrude with confidence. Custom extrusion equipment designed for you and your application.
Welcome to the MedX Podcast. I'm Steve Maxson. This is part one of a discussion with Teddy Mudge, Managing Director and Founder of Hoop Medical, based in Wexford, Ireland. Hoop Medical specializes in the development and manufacture of advanced balloons for medical device applications. Teddy, welcome to the MedX Podcast.
Thanks for having me, Steve. Yeah, it's great to be with you here on your show.
Teddy, to start off, please give our listeners a background about Hoop Medical, when and why you started, and where you are today, and what the future holds.
Yeah, sure. So I started Hoop Medical with my business partner, Clive Hayes. Clive is Irish and lives in Ireland. I'm South African and spend most of my time between South Africa and Ireland. But we actually first met each other back in 2012, and I was a design engineer designing balloon catheters, among other medical devices, and they were super challenging, difficult balloons. And I found Clive on that journey, actually at a trade show in Stuttgart in Germany. Mm-hmm. And from then on, Clive made these balloon components for me. And about 6 years in, the company that Clive was working for got acquired by a large multinational. And at that point, I was freaking out because now I didn't necessarily have a supplier for my balloon components. So it transpired that buyer was going to pretty much mothball a lot of the machinery or move it in-house. But regardless, they had decided not to service all the other customers, including me. So I, over the course of a few months, was chatting to Clive about what his next steps might be. And I made it clear that I was keen to start a balloon company, and Clive was keen as well. So yes, so over the course of about 6 months, we decided to actually go ahead and do it and take the plunge. And yeah, we haven't looked back since.
Walk us through some of the balloon types that you work with, compliance levels, and any unique applications that you might be able to share with us. And don't be afraid to just describe what compliance means when I say that to the listeners that might not be familiar with balloon technologies.
Yeah. Okay, cool. Yeah, so basically we make any balloon that can be made with a blow-forming process and a thermoplastic material. So what that means is basically certain polymers can be heated and reshaped and then cooled, and they will hold that new shape. And that's a thermoplastic. And we're limited to working with those specific polymers. Now that's a huge group. But it does exclude materials like silicon, and it does exclude materials like latex. And latex is old-fashioned. Some of the original balloons were made from latex, urinary catheters, for example. And nowadays, no one really wants to touch latex because it's allergenic, and I think between 2.5% and 4% of people have a reaction to latex. So these days, for those super compliant balloons, which is another word for very stretchy in that context, those kind of very stretchy elastic balloons like that used to be made with latex are now made with alternative materials that don't have these allergenic responses, and basically we do those materials. So while we don't do latex and silicon, we have alternative thermoplastics that work for many of those applications. So yeah, materials, it's thermoplastics. Process, it's blow forming. So blow forming is a very similar process to the way that plastic water bottles are made. So for those listeners out there who've kind of rotted on YouTube and watched water bottles getting pumped out by the thousands, it's basically you take some plastic which starts out in a shape. In our instance, it's often a tube, an extruded tube. But in the bottling analogy, it looks a bit like a test tube, the starting piece, which some people call a parison. And then to that plastic, you apply stretch. So you stretch it longitudinally. You apply temperature, heat, and you apply a pressure on the inside. And when you do those three things, you can get the plastic to expand outwards, radially outwards, and to fill a tool. So in this case, the tool is on the outside of the balloon, and you blow form the balloon out into the tool. And when it contacts that tool, it's prevented from expanding further outwards. And then you put it through a number of thermal processes to set it into that shape. And then you remove the pressure and remove the balloon from the tool. And that's your balloon component that you're left with at the end. And that's what we make and sell. That balloon component then goes on to get assembled onto a medical device, like a balloon catheter or a surgical robot or whatever it might be. Back to your question, we were talking about the types of balloons, and we touched on this idea of compliance, balloon compliance. Now, that's not to be confused with something like regulatory compliance. It's more of an engineering term for how much something will give when you apply force on it. So in this scenario, we're talking about a balloon, and these balloons, they get used for all sorts of different things. And depending on what the balloon needs to do inside the body, dictates what kind of a balloon you should design and make. And so one thing that balloons get used for is like dilation or dilatation applications. So those are when you're trying to use a balloon to open something up. And an example of that would be like putting a stent into a coronary artery, for example. You'd have the stent on the outside of the balloon. You'd inflate the balloon when your stent's in position. It would force open or dilate that stent, and you would then deflate the balloon, take the balloon out, the stent stays behind. That's a common use case for medical balloon. But they're also used for other things besides dilation, like, for example, occlusion. So to occlude either a blood vessel or some anatomy, you could think of a urinary catheter somewhat as a bit of an occlusion balloon. You know, the balloon is preventing the urine from leaking out, right? So but it's also kind of anchoring the device. So balloons can be used for anchorage. But you'll see, so in the scenario where you're wanting a balloon to expand something, you're going to want the balloon to put out a certain force or pressure. And often that pressure is high. And so sort of looping back to this idea of balloon compliance, a dilation balloon, which is perhaps needing a high pressure to exert a high force, that would typically be either a non-compliant balloon or a semi-compliant balloon. What it means is the balloon doesn't change diameter by much as you inflate it to higher and higher pressures. On the flip side, what you'd call a compliant balloon or a super compliant or ultra compliant balloon, that type of balloon is very stretchy, very compliant. So as you increase the pressure inside that balloon, the diameter of the balloon will increase a lot. And yeah, that's what balloon compliance is in a nutshell.
Okay.
Balloon stretchiness is what I like to sometimes call it. And we make all types of balloons, from non-compliant through to ultra-compliant. And we do that in two different ways. We have two different manufacturing processes around making those different balloons. But also, there's a lot of nuances within that. So, for example, there's different tooling types, and there's two common types of tools. What many people would call a three-piece tool, which is quite common for non-compliant, semi-compliant balloons of like standard shapes. But then your compliant balloons often have crazy shapes, very unusual shapes that can't be made with tooling like that. So another type of tooling that's quite common in industry is clamshell tooling, where the parting line is running lengthways down the balloon rather than running circumferentially, as is the case with the three-piece tool. So those are your two broad tooling types, and we have, as I said, different machines to work with those two different tooling types. But sort of within those tooling types, there are subclasses, and you can split tools in many different ways, and we sometimes have to do that to make some of these super challenging balloon shapes. There's been a lot of new technology, new devices requiring new types of balloons that we've been working on the last 3 years. And we're just sort of never quite sure what's going to come in the door next when it comes to the next idea that comes in from one of our customers. But yeah, so I mean, that's broadly speaking the different types of balloons we make. Long story short, pretty much any medical balloon, unless you need it from silicon, in which case we can't help you.
Thanks for listening to the MedX podcast. In part 2 of our discussion with Teddy Mudge, we get into more technical details about medical balloon forming and medical balloon designs.
Thank you for listening to MedX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. All links are available in the show notes.